In this video, we're going to discuss quadratic functions, all right? And in this discussion, we're going to mainly focus on, all right, so quadratic functions, but more importantly, another way to graph quadratic functions, all right? We've talked about quadratic functions that look like this. F of x equals a times x minus h squared plus k. And with these types of functions, we know that our vertex is given by the formula hk. All right, so that's a point that we can always literally just look at our function and see. And so it's going to be very important when we come up with a new way to graph these functions here. And that way that we're going to be using to graph these functions is by using shifts and reflections. And another way to say that is by using transformations. And the thing that we're going to transform is the function f of x equals x squared. All right. So if we know the graph of f of x equals x squared, and I'm going to draw this one quickly, you should already have it in your notes. All right. It goes through the point 0, 0, the point 1, 1, and the point negative 1, 1. All right. And so we'll have a parabola here. And so if I want to graph a function that is of this form right here, or this form right here, then all I have to do is look at this graph, because it's going to look very similar, but all I have to do is take all the points in this graph and either shift it or do a reflection, meaning transform it, to make it be this exact function that I see here. And this is how we're going to do this. We're going to look at the a. Okay, all right, and a is going to tell us whether we're going to reflect about the x-axis or whether we're not going to reflect about the x-axis. Reflect this function, f of x equals x squared, all right? If a is greater than 0, that means it's positive, all right? Before, when we talked about this, we said that when a is greater than 0, our function is going to open upward, all right? Well, if it opens upward, then that means I don't want to see something that looks like this, reflecting about the x-axis would make our graph of this f of x equals x squared look like that. And so since it opens upward, instead of reflecting about the x-axis, we do not reflect about the x-axis. However, if that a is less than 0, we do want to reflect. Right? Because a reflection about the x-axis means it's going to open downward. And as we said before, when a is less than 0, we open downward. All right? So we do reflect. All right? And so that's what a tells us. H and k tells us where to move all of our points. Either we're going to shift it to the right or left, or we're going to shift it up or down. H tells us our horizontal shift. Remember, horizontal means right or left. And so once we find our vertex, all right, we're going to look at whether that's positive or negative. If our vertex has an h that is greater than 0, then that tells us to shift h units to the right. And if h is less than 0, that tells us to shift h units to the left, right? And it's basically based off of wherever your x-coordinate of your vertex is, right? For instance, if h is positive, well, your x value of your vertex is going to be positive, so you need to shift to the right. And if h is negative, that means of your vertex, you need to go to the left in order to get to negative x values. And so that's why we shift to the left and to the right in that fashion. All right? So a tells us our reflections. H tells us our horizontal shifts, meaning go right or left. And finally, K tells us how we go up or down. And up or down means vertically. All right, so we have our vertical shift, up or down. And we already know how to find K. To find K, let's look at it. If it's greater than 0, we're going to shift K units up. And if k is less than 0, we're going to shift k units down. All right. And so since we know what these things mean, I'm going to give you some steps that you can take to graph using transformation of functions. And then we're going to get to domain and range. To graph using transformation of functions, first you got to be able to look at a function and pick out what actual transformations you are going to have. All right. Are you going to have a reflection about the x-axis? Are you going to have a horizontal shift? Are you going to have a vertical shift? Figure out if you have those transformations. Then what I want you to do is go to your graph and graph the function f of x equals x squared. Once you graph that, apply the reflections first to f of x equals x squared if possible, right? So if a is less than 0, you're going to do that. Otherwise, go to step 4, which is to graph your shifts, do your horizontal shifts, and then do your vertical shifts, and you will be able to graph your function. Once we graph our function, it'll be a lot easier for us to determine our domain and range. And remember that our definition for the domain is that it is the set of our inputs. And remember, when we're talking about functions, f of x is our input. So we say the set of our x values where the function is defined. And then you can find your range, which is your set of all y values where your function is defined. All right? And that'll be it for what we want to do in graphing and finding the domain and range. Let's look at an example. In this example, it says to describe the transformations and then graph f of x equals x plus 2 squared minus 4 and find its domain and range. All right, so I'm going to look at this function, right? I've got to be able to look at a, right? Here, my a in this example is 1. All right, my h in this example is -2. And my k in this example is -4. And if you can't figure that out, make sure you go back to a couple of videos back so you can be able to pick those things out. And so when a is equal to 1, that means it's greater than 0. That means we do not reflect. All right, h equals -2. Remember, h tells you you're horizontal, so that means you're going to shift to the left 2 units. And in k, that's negative, so you're going to go down 4 units. And so if I do that to my function f of x equals x squared, I'll be able to graph f of x equals x plus 2 squared minus 4. So let's do that. All right, I'm going to go to my graph, and my function f of x equals x squared goes through those 3 points, 0, 0, 1, 1, and -1, 1. And I always want to see at least 3 points. So I have my parabola here that looks like that. Now I'm going to do my first transformation, right? My first transformation says to do not reflect. Well, I don't have to do anything for that, all right? Now so that one's already done when I do my f of x equals x squared, which is right here. Now I'm going to go to my second one, which means to shift everything to the left 2 units. Well, if I shift everything to the left 2 units, all right, I'm going to label my points here. That's -1, 1, that's 0, 0, and that's 1, 1. If I shift this to the left 1, 2, how many units? 2 units. What I'm going to do is I'm going to take all of these points and shift them over 1, 2 units, and I'm going to draw it on this new graph here. And so the point -1, 1 will become the point -3, 1. And if I shift this to the left 2 units here, I'm going to go 1, 2. So I'm going to have the point -2, 0. All right. And if I shift this one to the left 2 units, I get 1, 2. I'm going to have the point -1, 1. And so now I can draw my parabola. A little sloppy there. But I got my points labeled so I know where it goes through. All right. And so I get a graph that looks like that. And so now in red, I've done this second transformation. So that one's done. And now I've got to shift everything down 4 units. And I've got to go from my red graph, and that'll be my solution. And so if I'm going to shift everything down 4 units, I'm going to take all of these points here and go down 4 units. So I'm going to go 1, 2, 3, 4. And I'll be here at the point -3, -3. So I'm going to draw that graph, -3, -3 here. I have the point -2, 0. I'm going to go down 4 units. 1, 2, 3, 4. That'll be the point -2, -4. So -2, -4. And then last but not least, I'll have the point -1, 1. I'll shift down 4 units. 1, 2, 3, 4. And I'll have the point -1, -3. And then I can draw my graph. And there is my graph of my final parabola there. All right. So this is my parabola. F of x equals x plus 2 squared minus 4. All right. And so now I want to figure out what the domain and the range are. All right. Let's start with domain. Remember, your domain is your set of all x values where your function is defined, right? And so if you think about everything on your x-axis, right, what points can you plug in, or if you look at your function or your graph, what are all the x values of all of your points on your graph? All right. For instance, we know that -3 is an x coordinate for this point right here, right? -2 is an x coordinate for this point right here. -1 is an x coordinate for this point right here. 0 is a x coordinate for this point right here, or some point. And in fact, every single point on your number line has every single x value on your number line is a point and is an x coordinate of a point on your graph. All right, and so our domain would be from -infinity to +infinity. Remember, we write it in interval notation, and that means all real numbers. All right, there is not a single x value that is not an x coordinate of a point on your graph. All right. Now let's go to the range. And when we're talking about our range, we're talking about our y value. So we need to look on our y-axis and see which y values are not coordinates, are not y coordinates to points on your graph. All right. And this is when you either start with your highest or your lowest point on your graph, right? The lowest point on my graph has a y value of -4. All right. And so what that means is every single point that's above where y is -4, all right, every y value above or equal to -4 is a y coordinate on your graph, right? Notice that at -5, there is no point on this graph of this parabola that has a y coordinate of -5. The same thing for -6, -7, -8, -9, -10. 4 is the smallest y value. And so my range, if I want to write that, is going to be from -4 on up to +infinity. And I include that -4 there. All right, so we have our domain and our range. Let's look at one more example. We're going to look here at f of x equals -x minus 2 squared plus 3, and we're going to go through that same process. All right. For instance, my a in this example equals -1, my h is 2, and my k is 3. Right. This a equals -1 tells me to reflect about the x-axis. H equals 2 means to go right 2 units. And k equals 3 tells me to go up 3 units. And so I'm going to start with f of x equals x squared, which always goes through the point 0, 0, 1, 1, -1, 1. And it is a parabola. All right, and I'm going to label my points. And then I'm going to start with my reflection about the x-axis, right? When I reflect something, that means I flip it across the x-axis, right? Meaning my y values to each of these coordinates is going to be the opposite, or the negative. And so the point -1, 1 is going to become now the point -1, -1. So I'm going to have the point -1, -1. The point 0, 0, well, if that's on the x-axis, so when I reflect it, it's still going to be on the x-axis. So that's going to be the point 0, 0. And last but not least, the point 1, 1. Since it's above the x-axis, if I reflect it, it's going to be below in the same spot or a similar spot. And that coordinate is going to be 1, -1. And so I get a parabola that looks something like that. That's a better representation. All right. And so that is my parabola, and I've reflected about the x-axis. Now I'm going to move everything to the right 2 units. Two units to the right, -1. -1 is going to become 1 -1, which we already have there. All right, so I'm going to have the point 1 -1. The point 0, 0 is going to become the point 2, 0. And the point -1 -1 is going to become the point 3 -1. And so I have a graph that'll look something similar to this right here. Okay. The last transformation that I need to do from the blue one, which I have right there, right 2 units, is to move everything up 3 units. So I'm just going to be shifting everything up 3 units, meaning my y values are going to increase by 3. So instead of the point 1 -1, I'm going to have the point 1, 2, the point 2, 3, and the point 3, 2. So I shifted all of my points up 3 units. And that is a little sloppy there, so I'm going to start over there. And I get this graph that looks something like that. And that one's sloppy too. All right, and so now it's time for me to find my domain and my range. All right, let's first start with the domain. Domain is set of all x values where your function is defined. All right, again, our domain is going to be from -infinity to +infinity. All right, that's because every single x value on my number line is an x coordinate to a point on that graph. So I can input any x value and I'll have an output. Now my range is going to be a little different. Again, I'm going to think highest, lowest y value, right? Notice here I have a maximum point, and so I have a highest y value, which is at y equals 3. And so my highest y value is y equals 3, and it includes all the x values that are lower than it, or below it, smaller than it, less than it. And so my domain, or my range, is going to go from -infinity, right? We always write it from lowest to highest, up into 3, and I include that 3, and of course we don't include -infinity. All right, and so that is my domain and my range. The last thing I want to talk about in this video is to finding the maximum and minimum values of a function. All right, we've done this before. I just want to do it one more time just so that we will know. All right, the maximum or minimum value. Here I'm talking about value. Keyword here is value. All right, we've talked about maximum and minimum points being the same thing as your vertex. But when I specifically ask you for the value, I'm looking for you to think of your vertex, but I'm specifically looking for your y coordinate. All right? And that is where it's related to your range, right? Your range gives you the highest or the lowest y value, right? If you look, that 3, y equals 3, that's your maximum value. That's the y coordinate of your vertex. And so what we're going to do is we're going to look at a couple of examples where we just go ahead and find the maximum or minimum value. All right? So in this example, we have f of x equals -x squared plus 24x minus 76. And we want to find the maximum or minimum value. So in this form here, our vertex is given by -b over 2a, and then we f of -b over 2a. So we actually got to find our x coordinate first. So I'm going to do -b over 2a, right? My b is 24, so I get -24, and my a is -1. And so I get this here. That'll be -24 divided by a -2, which is a positive 12. And so my solution here is going to be f of 12, which is equal to -12 squared plus 24 times 12 minus 76. And that is going to equal 68. Now, one thing that I forgot to do was determine whether it was a maximum or a minimum value. And one thing that'll help us is to be able to determine what that a is from our formula. And remember, a is always the coefficient on your leading term here, which is a -1. And since that's a -1, I know that my vertex is going to be a maximum only because this opens downward. So since that opens downward, since that is negative, I know that my parabola is going to open downward. And since it opens downward, my vertex is going to be a maximum. So my maximum value is 68. Okay, let's do one more example. We're going to look at this example here. It says find the maximum or minimum value of the function f of x equals 7 times x minus 4 squared plus 46. All right. This one is a lot simpler because you can just look at it and tell. First, I'm going to determine whether I'm going to have a maximum or a minimum value. Well, here is my a. It is positive. That means my graph is going to open upward. And when my graph opens upward, my vertex is going to be a minimum. All right, so we know for a fact that we're going to have a minimum value. All right, we'll determine that minimum value by finding the y-coordinate of our vertex. Y-coordinate of our vertex. Well, what's nice about this form, when it's written in this form, the y-coordinate of our vertex is always this number that's sitting out here. Right, it's a plus 46. That means that our y-coordinate of our vertex is 46, so our minimum value is 46. And this concludes our video on quadratic functions.